Hello everyone, this is Anishu, and in my previous video I have shown you the implementation of a full web API without integrating a database. Today in this video I'll be taking it a step further by delving into the database and adding a persistence layer to my application. Before delving into the persistence layer, let's quickly recap of what I covered in the previous video to provide some context. In the previous video, I built a full web API using ASP.NET Core, focusing primarily on handling HTTP requests and routing. While the full web API was fully functional, it lacked the ability to store and retrieve data persistently. And that's where the database and the persistence layer comes into play. Integrating a database allows our application to store data securely and retrieve it whenever needed, significantly enhancing its functionality. Today, I'll be walking you through the process of integrating a PostgreSQL database into the full web API application. We'll set up the necessary tables and dive into the code to see how the database interaction is handled. First of all, let's start by creating our database in the PostgreSQL. I won't be explaining the process of installing the PostgreSQL and pgadmin because I believe you will be able to do them yourself. So let's directly dive into the tables that I have created. I have used Azure Data Studio IDE to interact with my database. So let's begin. As you can see, I have already created a database named SIT331 and also made the tables for it, namely map, robot command and user. For now, ignore the user table as it is not necessary in this implementation. I'll be showing the use of the user table to create the authentication layer in future videos. I have used create table commands for Postgre to create these tables, and I have used insert commands to insert values into them. I'll not be showing the script that I have used to insert the values into these tables, as I believe you will be able to do them yourself. Now let's check the values that I have inserted in these table. For the robot command table, you can see that I have inserted 5 values: left, right, move, place and report. Similarly, for the map table, you can see that I have inserted a few maps to the table already. Now, to back up this database that I have created, I'll be using the pgdump command in the terminal to create a SQL file. This SQL file can be used to back up the database and create it anywhere else. After running the pgdump command successfully, you should be able to see a file similar to this one. It contains information about all the commands that I have used to create my database, and it will help you to back up your own database if required. With this, our database is now set. Now let's see how we will be connecting it with our code and implement the persistence layer in our application. In our full web API implementation, we will create a new folder named persistence. This folder will contain the files for the CRUD operations in the robot command and the map tables respectively, and will fetch data from the database directly. Before diving into the code for the persistence, I'll like to show you that the robot command and the map model both are not changed at all from the previous implementation. But there will be some changes in the controller files as we will be connecting the database into them rather than using a static list that I have implemented in the previous video. Similarly, the rest of the implementation remains the same. To implement the PostgreSQL database in our application, we need to install its driver in our project. For that, we will be installing the npgsql library in our project. First of all, coming to the robot command data access file. In this file, we will be using the database driver that we have installed earlier. Now, in the robot command data access class, we are handling the database operations related to the robot commands within our web API application. At the beginning of the class, we define a connection string. This string contains the necessary information to establish a connection with the Postgre database, including the host, username, password, and database name. The getRobot commands methods retrieve all the robot commands from the robot command table in the database. It establishes a connection, executes a select query, and reads the data using data reader. Each retrieved row is then mapped to robot command object and added to a list. The update robot command method updates an existing robot command in the database. It executes an update query passing parameters to the updated values such as name, description, isMove command, and modified date. The insert robot command method inserts a new robot command into the database. It executes an insert query passing parameters for the command's properties such as name, description, isMove command, created date, and modified date. Finally, the delete robot command method deletes a robot command from the database passed on the provided ID. It executes a delete query with parameters for the command's ID. In conclusion, the robot command data access class plays an important role in facilitating database interaction within our full web API application. Similar to the robot command data access file, in the map data access file, we will be using the npg SQL driver as well. Now coming to the map data access class, this class is responsible for managing the database operations related to the map within our web API application. Just like our previous class, we will begin by defining the connection string. This string holds the essential information needed to establish a connection with the PostgreSQL database. The getAllMaps method retrieves all the maps from the map table in the database. It opens a connection, executes a select query, and reads the data using a data reader. Each map is then mapped to a map object and added to a list. Moving on to the update map method, it allows to update existing map entries in the database. By executing an update query, we can modify columns such as columns, rows, name, description, and modified date based on the provided ID. The insert map method enables the insertion of a new map entry into the database. It executes an insert query passing the parameters for the map's properties such as columns, rows, name, description, created date, and modified date. Finally, the delete method deletes a map from the database based on the provided ID. It executes a delete query with a parameter for the map's ID. In conclusion, the map data access class provides us with the necessary requirements to interact with the map data within our full web API application. With that, I have completed the explanation for the map data access and the robot command data access files, and completed the explanation for the database connection or the persistence layer in my project. Now coming to the changes that are required in the maps controller and the robot commands controller. In both the controllers, that is the robot commands controller and the maps controller, we will be removing the lists that we have implemented in the previous video. That list is not required anymore as we have implemented the persistence layer. After that, we will be calling the robot command data access class and the map command data access class into the controllers folder. We will be doing that by referencing to the persistence folder with using statement at the beginning of our code. After that, we can call all the methods that are contained in robot command data access class and the map command data access class into the robot commands controller and the maps command controller respectively. The rest of the implementation basically remains the same, with every reference to the static lists in the previous implementation being replaced with the reference to the robot command data access class or the map command data access class, thereby referencing to the database itself. With this, our persistence layer implementation is complete. Finally, I will show you the demo of the project in working. After running my application and opening Postman to run a basic GET request, I can see that the GET request returns the values that are equal to the values that I have inserted in the database. Similarly, I will run for all the requests. Similarly, when running a post or put operation and checking the database, I can see that there are changes in the database tables. Finally, running delete method shows us that there are entries that are being deleted from the database. With this, I have shown you the implementation of the persistence layer in my full web API application. In the next video, I'll show you how to do dependency injection or object relational mapping. So definitely stay tuned for that one. Thank you.